A very good morning, my dear students. I hope everybody is doing great. Let's continue the chapter called Units and Measurements. We have started with a topic called dimensions. In the dimensions, after the introduction, we have started dimensional analysis. In the dimensional analysis, two applications we have done. Number one, converting one system of units into the other system. And number two, principle of homogeneity. On the principle of homogeneity, we are solving some numericals. And some other numericals are in this form. So these two numericals were asked in the previous NEET exams. If you want, you can check the previous year exam questions in units and measurements chapter. You get similar to these example questions. All right, let us start the first question. The dimensions of alpha by beta in the equation f is equal to alpha minus t square by beta v square, where f is a force, v is a velocity, and t is a time, right? How many physical quantities they have given? Force, velocity, and time. And what are the other quantities are present in the equation? Alpha and beta. So you can imagine that alpha and beta are constants, okay, which will have dimensions, okay. So this alpha by beta means dimensions of alpha by dimensions of beta. They are asking us to find out. Let's see. This is the given equation. Look at the given equation carefully. What is that? F is equal to alpha minus t square divided by beta v square. I've told you, according to the principle of homogeneity, any equation you consider, any equation, if there is an addition or subtraction is going on between any two physical quantities, the dimensions of them must be same. Understand? Again, I'm telling you, according to the principle of homogeneity, if there is an addition or subtraction is going on between two physical quantities, the dimensions of them must be same. Alright? Clear? Now, where is the addition is going on here between any two quantities? So there's no addition, but there is a subtraction is going on between these two quantities. One is alpha and another one is t square. Right? So what I'm writing, according to principle of homogeneity, what happens? Look at here. According to the principle of homogeneity, dimensions of alpha must be equal to dimensions of t square, whereas this t is given as time, and I can say it is having the dimensions of t square like that. So the dimensions of alpha, let's consider this is an equation 1. Clear? Sure? Now how to find the dimensions of beta? So this is one quantity minus another quantity. Both will have same dimensions. So these two quantities, when you subtract, you will get a quantity that will definitely have similar dimensions of either this or this. Okay? Clear? See, dimensions of alpha is t square and dimensions of t square is also t square. So when these two quantities are subtracting, definitely you will get a quantity that must be equal to the dimensions of either this or this. So I'm writing, according to the principle of homogeneity, what happened? And dimensions of this f is equal to, so here the numerator I'm writing, it is dimensions of t square, because this dimension t square and this dimension is also t square, divided by dimensions of beta into dimensions of v square. So what we need? We need the dimensions of beta, and let me write. So the dimensions of beta is equal to t square divided by dimensions of force into dimensions of v square. Alright. So the dimensions of t square divided by f. Force dimensions are m, l, t minus 2. Force, mass into acceleration. Clear? Into v square. Dimensions of velocity is lt minus 1. It is square. So this will be l square t minus 2. Okay. Now take everything to the numerator now. So the dimensions of beta will be, so this is m minus 1. This is L. Alright. See, for your better understanding, let me write one more step here for that you will be so much comfortable. So this m as it is, I am writing L into L square, it is L cube, t minus 2 and minus 2. So that will be t minus 4. Okay. Now this can be written as t square in the numerator divided by, so this m minus 1, L minus 3, right? So this is t minus 4 goes to the numerator, that will be t plus 4, right? Everything I have taken to the numerator now. So from here, so what I can write, the dimensions of beta will be m minus 1, L minus 3, and this is t plus 4 plus 2. So that will be t to the power 6. So this is equation number 2. Now the question is equation 1 by 2, which is equal to dimensions of alpha by dimensions of beta. And let me write the dimensions of alpha. The dimensions of alpha we have found here, it is t square by dimensions of beta will be like this, m minus 1, L minus 3, t raised to 6. Okay, so this I can write, m minus 1 goes to the numerator, that will be plus 1, m. L minus 3 goes to the numerator, that will be plus 3. So this is t square, and this 6 goes to the numerator, that will be t minus 6. 2 minus 6 will be t raised to minus 4. So that is your answer. Clear? So my dear students, in this way the principle of homogeneity can be applied here. At the end of the dimensional analysis, and we will be understanding some limitations of dimensional analysis. What is that? Limitations of the dimensional analysis and some other questions, some extra questions based on principle of homogeneity we will be learning there. There are some more models we will learn based on principle of homogeneity. For that, you should understand what limitations of dimensional analysis. In all the cases, this dimensional analysis will not work out. Only in some cases it will work out, and those cases we are discussing now. Alright? So see the next question. So this is the most frequently asked question in the NEET, JEE or CET exams from the dimensional analysis. Look at here. An equation is given here in this way. P plus A by V square is equal to B into theta by V, where P is pressure. This P is pressure. It's not linear momentum, understand? So you should not consider it that way. And V is volume. So V is volume. This V is not velocity. Okay. And theta is absolute temperature. Temperature. If A and B are constants, find the dimensions of A. A and B are constant, find the dimensions of A. So simple. According to the principle of homogeneity, again I am telling you, according to the principle of homogeneity, what happens? In the given equation, identify where the addition or subtraction going on. Again, I am telling you, see, this may be the 15th or 16th time from the concept of principle of homogeneity. Whenever a question is given in this way, identify the addition or subtraction going on between two quantities in the given equation. See, there is an addition between P and A by V square. Immediately the dimensions of this must be equal to dimensions of this. So dimensions of P is equal to dimensions of A by V square. Okay, so this I can write it as dimensions of A divided by dimensions of V square. Alright, so from here, so from these two, what I can write, dimensions of A will be equal to dimensions of P into dimensions of V square. So what is this P? So P is force per unit area. Understand, pressure is force per unit area. Because I could not remember the dimensions of the pressure directly. So in this case, what we can write? We can write pressure is force per unit area, where force is mLT minus 2 and area is L square. So this is mL minus 1 T minus 2. That's a pressure. It's dimensional formula of the pressure. Okay, so the dimensions of A will be in this way, mL minus 1 T minus 2 into, so this is volume. Volume is L cube. So that is L cube whole square. So that will be L raised to 6. So the dimensions of A now mL5T minus 2. Is it clear, my dear students? Dimensions of A. mL minus 1 plus 6, it's 5T minus 2. So this is how the questions asked based on principle of homogeneity. Now we'll be moving into the third dimensional analysis and its application. My dear students, let us have a look at application number 3. As I've told you already, and this is, the concept is more theoretical. For your theoretical exam, this question and this type of questions are very, very important. Whatever the theory exam you write based on units and measurements chapter, definitely for the long answer type question, you get such kind of questions. See what exactly the application number 3. It is deducing the relation among physical quantities. Equation they have not given. Some physical quantities they give. You need to find the equation which is formed because of all those physical quantities by using the dimensional method. By using what? A dimensional method, and it is one of the application of dimensional analysis. Are you ready? Let's see the question. The time period of oscillation of a simple pendulum. What is the time period? This is not required in this case, but still, what is the time period? Time period is the time taken by an object or a body to finish to and fro motion. That's it. Time taken by a body to complete one oscillation. One oscillation includes one to motion and one fro motion. I hope it's very clear for you. Let me tell you once again. Time period of a body is the time taken by the body to complete one oscillation. Here, what they are asking about, time period of a simple pendulum. In your lower classes, you might have learned about the simple pendulum. This is a rigid support and this is called length of the pendulum and this is called a metal bob. Right? So this is the center point of the metal bob. From the rigid support till the center, so this is called length of the pendulum. What is it called? Length of the pendulum. So don't consider that length of the pendulum is still here. No. This is length of the pendulum. And the mass of the ball, generally this is an iron ball, right, or a steel ball. That's a metal ball. That's called metal ball. You know, acceleration due to gravity is denoted with a small g. So this is called the mean position. Understand? So this is called what? A mean position. From the mean position only, we take the metal bob to some extent and release. It oscillates above the mean position. Clear? The time taken by this body to complete one oscillation is called the time period of the pendulum, and it is denoted with the symbol capital T. Alright? Read the question once again. The time period of an oscillation of a simple pendulum is depending on length of the pendulum. It's depending on what? Length of the pendulum. And it is depending on what? Mass of the bob. And it is depending on what? Acceleration due to gravity. So the question is, time period of a simple pendulum is depending on all these three factors. Remember, they have not mentioned as how the time period is depending on them. Inversely proportional or directly proportional or square of the directly proportional or cube of the inversely proportional. They have not mentioned it. They have just mentioned that the time period of a simple pendulum is depending on these three quantities. Derive an expression for time period by using dimensional method. Okay. So, the method to solve such kind of questions in this application is same for every question. Same for every model. Here itself, we will be solving one more question and I'll give you classwork, some other questions along with the homework. Are you ready? Let's see. The first step, how you have to do that and why you need to do that, I'll tell you. What is given, the answer will be like this. Given time period of a simple pendulum is depending on, I'm just simply considering that time period of a simple pendulum bob is directly proportional to, I'm considering directly proportional to length of the pendulum, okay, mass of the bob, and this acceleration due to gravity. Carefully see. You may get a doubt. Sir, this time period, why you took directly proportional? It may be inversely proportional also. This mass, why you took it is directly proportional to the time period. It may be inversely proportional. This time period, why you have taken directly proportional to acceleration due to gravity. It may be time period is directly proportional to square of the acceleration due to gravity. Understand? So the answer for your question is, to avoid such kind of confusions, what I am doing here is, I am just writing L raised to A, M raised to B, G raised to C. If you find A, B, C values, and you will understand whether the time period is directly proportional to the L or inversely proportional to the L. Listen. For example, after solving, if your answer is A, if the answer for this A is -1, then what happened? So L raised to -1 means 1 by L. So that indicates your time period will be inversely proportional to L. Again, I am telling you. If your C value is -1, listen, if your C value is -1, so that means G -1, G to the power -1, so that indicates it's 1 by G. So finally, the conclusion is that time period will be inversely proportional to G when C value is -1. When C value is 1, if I get C value is 1, G raised to 1, that's nothing but G. Time period is directly proportional to G. You got the point? First step, what I have done, time period is directly proportional to what are the factors they have mentioned. I have written them. Each one I have raised to the powers A, B, C. Here, this is the equation. I can also write the time period is equal to, when I remove the proportional symbol, there will be a proportional constant, and that is K here, into L raised to A, M raised to B, and G raised to C. Okay. Let's take this as an equation 1. Carefully see. The procedure will be same for every question based on application number 3. Let's write the dimensions of them. Okay, let us write the dimensions of this. So let us write the dimensional formula for this equation. Time period dimensional formula. So I am writing this is M0 L0 T1. Is it the time period? Because it is simply time period T. That's why I just wrote M0 L0 also. There's no difference. This K will not have any dimensions because it is a constant. It will be a number. Okay. Now, proportional constant. It is a number actually. It will not have any dimensions. L is length. So length dimensions I can write M0 L1 T0, right? To avoid your confusions, I have written in this way. Alright. M, mass M1 L0 T0. So that is to the power B. And the last one, it will be G to the power. See, G is what? Acceleration due to gravity. So that L T minus 1. So that is, I can also write M0 L1 T minus 2 raised to C. Clear? What I have done here, simply K, not C, T dimensions, K, no dimensions, L, M, L1 T0 to the power A, M, L0 T0 to the power B, M0 L1 T minus 2 to the power C. Okay. Now, M0 L0 T minus 1, which is equal to, right? Carefully see. M to the power 0 into A, right? M to the power 1 into B. M to the power 0 into C, and L to the power 1 into A, L to the power A, L to the power 0 into B, L to the power 0, L to the power 1 into C, L to the power C. Right? So those are the things I'm just going to write here. Here, first all M's let me write here. M to the power 0 into A is 0. Right? Here, plus M to the power 1 into B. So that's M to the power B. Alright. M to the power 0 into C. So that M to the power 0. You understand? My dear students, it is so simple. M to the power 0 into M to the power B. How much? M to the power 0 plus B. See? For your better understanding, let me add one more step as it is a first numerical for you. Do not get confused. M to the power 0 into A is 0. M to the power 1 into B is M to the power B. M to the power 0 into C is M to the power 0. All M dimensions are done, finished. L to the power 1 into A, it's L to the power A. L to the power 0 into B is L to the power 0. L to the power 1 into C, it's L to the power C. All L dimensions are done. T to the power 0 into A is T to the power 0. T to the power 0 into B, it's T to the power 0. Right? T to the power minus 2 into C, it is T to the power minus 2C. T is also finished. m0 L0 t minus 1 is equal to what I can write here, m to the power 0 plus 0 plus 0, and here L to the power a plus 0 plus c, and here t to the power 0 plus 0 minus 2c. Okay. Alright. Now, m0 L0 t minus 1 can be written as m to the power b, there is 0 plus c, b plus 0 is 0, b. L to the power a plus c and t to the power minus 2c. Okay. This is left hand side and right hand side. When left hand side MLT and their powers, and right hand side also MLTs are there, their powers are also there. Understand? So here we can equate the powers by equating the powers in LHS and RHS, left hand side and right hand side. There is an equation we have got, or a dimensional formula we have got. So then their powers can be equated. M raised to 0 and this is m raised to b. So then this b is equal to 0. I'm just writing powers need to be equated, right? So p is equal to 0. And here a plus c, L raised to 0, L raised to a plus c. So what I can write, a plus c is equal to 0. And last, minus 1 minus 2c. Okay, so this is not minus 1. Sorry, here it is plus 1, plus, so we have missed it. So this is plus. Here itself, 1 is clearly written. So here it is plus 1, plus 1, plus 1. Now let's equate. Plus 1, t raised to 1 here, and it is t raised to minus 2c. And I can say it is minus 2c is equal to 1. Okay. Clear? Now, so look at here. From this, I can write c is equal to minus half. So b is equal to 0. And a how much? See, from here, what I can write? A, c is minus half, right? A minus half is equal to 0. And from here, a is equal to plus half. So a is equal to plus half. Look at here. Your a, b, c values we have got. So let us substitute this in equation number 1. Let's substitute in equation number 1. What is our equation number 1? What is our equation number 1? T is equal to some constant into L raised to A. What is L raised to A? A is 1 by 2. M raised to B. What is our M? M raised to B is 0. And G raised to C. What is our G raised to C? C is how much? Minus half. Have a look at the answer. This is not the final answer. T is equal to C. Derive an expression for t. This is not the expression for t. We need to bring the final time period into an equation form. T is equal to k into L raised to 1 by 2. Okay. M raised to 0 is 1. M raised to 0 is 1. G raised to minus half. So I can write it is divided by G raised to half. Because when this denominator g raised to half is taken to the numerator, that will be g raised to minus half only. No confusions. My dear students, I hope you are understanding. Now, this can be written as k into L by g all to the power 1 by 2. This I can also write it as t is equal to k into square root L by g. This is the final answer. So how the time period, length of the pendulum and acceleration due to gravity are related in this way, right? So where is the mass here? As we have got m is raised to the 0, so that means time period of a simple pendulum is independent of the mass of the bob, right? From this, what we could consider, what we could conclude, time period of a simple pendulum, time period of a simple pendulum is independent of a mass of the bob. What is that? Independent of the mass of the bob that we have got from here. So because in the final equation there is no mass, you see. You got the point? Clear? Now, what exactly meant by this statement? Time period of a simple pendulum is independent of the mass of the bob. Come back to the simple pendulum diagram. Imagine the mass of this bob is 1 kg and it is oscillated. Time taken to complete one oscillation is 10 seconds. Instead of 1 kg, if you keep a bob of mass 10 kg and oscillate, time taken by the same pendulum to complete one oscillation will again be 10 seconds because it is independent of the mass. The time period is independent of the mass of the bob. It is depending on length of the pendulum and acceleration due to gravity. Length of the pendulum and acceleration due to gravity. Alright. It is directly proportional to the length of the pendulum and inversely proportional to the acceleration due to gravity. Alright. Just pause the video, write it neatly, practice once, and let's move forward. My dear students, this is the classwork for you based on the previous numerical. That's the reason I told you pause it and go through the question and answer once again before starting this classwork. Step by step how we have solved the previous question, you follow accordingly for these 3 questions. If you are able to solve these 3 questions correctly, then the application number 3 is done. We can happily move for application number 4. Alright, let's start the first classwork question. I'll just explain the rest, everything you have to do it. If centripetal force F is depending on mass of the body, speed of a moving body, and radius of the circular path, there is no information is required or needed regarding centripetal force. What is the centripetal force? Why the centripetal force? It doesn't matter to us now for time being. We need only to find the relation among force, mass, speed, radius of circular path, and you need to find the expression for the force in terms of mass, velocity, and radius of circular path. Same way, the speed of the sound wave, you can imagine the speed of the sound wave is v, and the speed of the sound wave is depending on the wavelength and the frequency. You may be knowing the relation actually. You may be knowing the centripetal force relation here also. I don't want the final answer. I need to proceed by using dimensional analysis or by using dimensional method. How could you solve the relation among those physical quantities is matter. If kinetic energy K, depending on the velocity, acceleration and density of an object. Kinetic energy is depending on these 3, they have told. Velocity, acceleration and density. What is the expression for kinetic energy in terms of velocity, acceleration and density? You do it. Pause the video, send through to your WhatsApp as soon as possible before your online assessment starts. All the very best. See you soon. with the next dimensional analysis.